So here we're going to be looking at the IEnumerable interface. This is an interface that comes with C Sharp. It's extremely useful. It's actually one we use when we pass in a list into a for each. A for each needs a specific method to call in order to be able to properly iterate through it. Here we're taking a look at the IEnumerable information on C Sharp corner. We'll have the link in the page. It says to describe what it is, IEnumerable is a C sharp in C sharp is an interface that defines one method, the getEnumerator, which returns an IEnumerator interface. This allows read-only access to a collection. Then a collection that implements IEnumerable can be used with a for each statement. Yeah, so it just means that what we can do now is if we create a class that has some kind of list inside of it, we can go ahead and um, inherit IEnumerable, and then if we construct the code properly, we can pass in the class instance itself instead of the list in order to go through that list through a for each. Let's go ahead and take a look at how to implement that. Here you'll see I already have some code up. I created a class called class roster. This is a class that just represents whatever the list of students that I'll have inside of my class. You'll even notice that I have a list of student right here. This is a very basic class. It just has this list. I go ahead and then I have a property to display the list so that we can access it. And then I have two methods in order to add students to the list. Because if we recall, I don't want people to have direct access to do that kind of stuff. So I have this add student class. If we take a look over here, my student class is simply its own class that has a first name, last name field, a constructor, and I override the two strings so that way we can just display first and last name on it. So it's all very simple. The only key thing I want to call out here is on my methods, I made sure to overload my methods. I wanted to give the option where if someone created a student object, they could pass that in to add the student. Or if we wanted to, they could just pass in a first and a last name because that's what our new student constructor took. And then we can pass in that first and last name and then construct a student inside of our code. Two different ways to approach it. It's all down to the usability for our users. So now if I came back over to my program, we can see what all this code represents. So this is where I created a new instance of class roster, and I did it for programming 124. I went ahead and I added 5 students. That would be myself, Professor Ann Nguyen, and then our TAs Hannah Angel, Dylan Register, and Kristen Taniguchi. Now, all of this is leading up to the important part about IEnumerable is our for each loop. You'll see that I've constructed this in console. It really doesn't matter where you build it. You can use this for WPF forms. You can use this for Win forms. You can use this .NET MAUI. Any place that you would want to use a for each, this is applicable. But here we went ahead and we can see that I'm looping through. We're taking a look at students. And then this is the important part. Here I'm doing this with our programming 124 class roster, but I'm having to access that list on the inside, the students list. This is actually not best practices. For something like this, we would want to restrict it so we're not accessing this internal list. So that's what we're going to be looking at with IEnumerable. And just to show you our current result right now when we run this is it displays our names just as we've added them. And so in our next step, we're going to go ahead and in our class roster, we are going to implement the interface IEnumerable. All right. So to implement IEnumerable, I'm going to come over here to class roster because I'm coming over to class roster because this is the class that has the list that I'm going to want us to end up enumerating through using our IEnumerable on. Specifically, I'm going to want to make it so that we can use our students list with that for each. So what I'm going to do here is I'm going to inherit the IEnumerable interface. So to do that, again, we just do colon and I do IEnumerable. You'll notice that we have two options. There's the one with the little less than greater than symbol. That's going to take a specific type, like string, student, whatever. Right now, we're going to ignore that. We're just going to straight out do IEnumerable. Notice again that it's yelling at us. That's fine. I'm going to go ahead right click, quick action, implement interface. And down here, it generates our IEnumerable method. It generates this public IEnumerator get enumerator. This is the very method that our for each will use. This is the important thing that we need to make sure to implement properly. But you'll notice that it's returning an IEnumerator. What is IEnumerator? Well, that is something else we're going to have to construct. That's where this starts to get a bit more complex. Let's go ahead and take a look at that. So here we're having to throw back our IEnumerator, right? Well, what is this? How can I get this? Where is this coming from? Well, what an IEnumerator is basically going to be another class that we are about to create that tells our code, specifically the get enumerator, how to interact with this list. Again, this list that we're working with is our student list up top, this field. Let me go ahead and enlarge this. It's this list up here. So now inside, notice that right now I am inside, this is my class, this is my namespace. Inside, I'm creating an internal class. So we can build a class inside of another class. The only thing that'll have access to this class is this class itself. So that means when I build this internal class, only class roster will have access to it. That's fine. That's all that matters. So I'm going to go ahead and name it private. It's going to be class. I'm going to call it get class roster enumerator. Go ahead and do my curly braces. Notice it's not yelling at me. It takes an internal class just fine. But now what we need to do is now we're going to inherit this IEnumerator. IEnumerator. There we go. It's now yelling at me again. I'm going to right click quick action and implement interface. We see that it has now given us our one property and two methods to work with. This is all it takes in order to get a class enumerator to start working with your IEnumerable. Let's go ahead and see about getting this all set up. Okay, so now here we are. We have this code. What do we have to do? We have a lot of exceptions being thrown because nothing's set up. That's okay. Let's go and take care of it. It's not nearly as complicated as it may look. We're going to start down here with just our IEnumerator. Up here, I'm going to go ahead and I'm going to create some fields. There are two fields I'm going to create. The first one is a int index equals -1. This is keeping track of the current index we're looking at. This is what our for each is going to use. So we're going to indicate it -1 because this indicates it's at the start of our collection. That's it. The next thing we're going to do is we're actually going to create another list of student. And we're just going to call this one students. We're not even going to initialize it. We're just going to do a list of students. Now this will change depending on the list you're working with. Notice I'm working with a list of students up here at the top. So that's why I'm declaring a list of students here. Now I'm going to come down here. I'm going to create a constructor. And this constructor, we can build it like this. This constructor is just going to, this is what we're going to use to return our class roster. And what we're going to do is quick action and generate it to take a list of students. This is it. It's going to take a list of students. I'm actually going to end up passing in this list into this constructor. And we'll take a look at that in a second. That has an extra step, but it's important. Make sure to pass your argument as a reference. And to do this, place ref in front of your parameter. Wow, I went wild with that. Here, we're doing ref here. We're putting this keyword reference. This is saying, hey, we're passing in something. Whatever we're passing in is as a reference. And as a reference, it means that it is attaching the address to it, the address in memory for it. So there's a longer conversation behind that. All you need to know now is make sure to pass in ref here. And notice that whatever we're passing in, so the list that will come from up top is going to be attached to this list. That's all it takes. Now we're going to be working with lists. this list. That's all that matters. So here for our current, let me shrink this up. What does our current need? It just needs what the current object is at the index. So we're going to use this index. This index is keeping track of where we're at. And so I'm just going to say students index. That's all this takes. I moved the constructor down. Property. There we go. So current is always just going to return whatever it's looking at in the list. Basically, if you were to take a look over at our program again, our for each, that current is this. That current is whatever it's currently looking at right now. So that's what this represents. So it makes sense if we take a look at our code that it's always returning the current index. Let's come down here to our reset first. Reset sets the index back to before the first value, first element. And I say before specifically because it's here that index is going to equal -1. Same thing we have here, right? Because you'll see all of that ties into our move next. Move next gets called every time it's done looking at an object. We do move next, moves to the next one, moves to the next one, over and over again. So move next takes two parts. Is called to iterate to the next index. And because of that, we know this, we've done this in a for loop. It does index plus plus, I plus plus, right? Iterates to increments. We'll do increments to next index. That looks good. Now, notice here that it returns a bool, though. What's it need here? Well, this is where we have our last thing. This is honestly the most complex part about all of this. Indicates if at the end of the collection. And we're going to, this statement here is this. If index is greater than or equal to students dot count, return false, return true. Stop yelling at us, and now let's take a quick look at this. Here we're saying if our index is greater than or equal to a count, dot count, right? So this means if it is past if we've exceeded the number of elements in our array, right? Have we exceeded the number of elements in our array? Have we gone too far? Now we risk breaking our stuff, right? If it has gone too far, it will return false. So if it is at the end of our list, it will return false, else return true. I don't know what the for each is doing exactly, but if I were to guess, it's saying, hey, are there still more elements? And this is what this is checking for. If there are more elements left, return true, else return false. Or I guess let's flip this. If there are no more elements to look at, return false, else return true. There we go. That's basically what this is saying here. And that's all the code we need for our IEnumerator. Again, we've created a couple extra fields. A single field to keep track of our index. We started at -1. We create this a variable name to reference our list, which is going to be the student list. So it's the same exact type list student. We created a constructor that will take a list of students, and you notice it just connects the two right here. But most importantly, we went ahead and added ref in front of it to indicate that it's a reference. Just do that. For our three specific, our interface property current, we're just returning the student at the current index. With our move next, we've built it so that when it gets called, it's going to increment the index by 1. This happens first. And then down here, we have this if statement that's saying, hey, are we beyond the capacity of our list or array? Return false, otherwise return true. And in the very last method, we're just resetting that index to -1. This is what we need for our IEnumerator. Now we're going to take a look at how to implement that here in our get enumerator in our class roster. So here in our class roster, remember, this is an internal class. We've built all of this, but now we actually have to use it. So here, notice that it's returning an IEnumerator. Here we created our IEnumerator. So now we're going to go ahead and we're going to return a new class roster enumerator, right? Remember that we're passing in a list of students. So we're going to pass in this list, this students list. There we go. But it's still yelling at us. What's going on? Notice here it is saying argument must be passed with the ref keyword. So I'm going to say ref. There we go. Notice it stops yelling at us. Now if I come back over to my program, everything we just did, all that code was for this. So before I was using my students list, I was accessing that students list, right? Run my code, see it displays everything. That's just fine. Now though, I can come over here. I'm going to delete students. Notice that it is still working. It is not yelling at us. Let's go ahead and run the code. Notice that it works properly. What we have done, what this IEnumerable has done, is said, okay, when we pass in an object, if it has an IEnumerable on it, and we pass it into a for each, we're going to have this code written that says, hey, there's a collection someplace in here. There is an array or a list or whatever, and we are going to give you the code. We are going to write the code so that you can go through it like you normally do. The for each has not changed. The for each will work the same exact way no matter what, but we're saying our class roster has now implemented the code needed to work with the for each, right? It's like if you create an engine for a car, the car itself is going to have the components to connect to many engines. And the engine itself is going to be built in a unique way that makes it different from other engines, but it's still going to make sure to have certain valves and different connections so that that engine connect with the car. Same thing here. So now we've gone ahead, we don't have to access that internal list. This is good, this is more secure. In fact, now we can come over to our class roster, and inside of my class roster, I'm even going to delete this property. I'm deleting the property for students, and if you take a look right now, there's no way for our users to get access to the list outside of using a for each or using the methods that we have built for it. That has made this more secure, easier to work with, and has allowed us to kind of dictate how our code works with the rest of the program. That's the importance of interfaces, and here IEnumerable.